Okay, in this video we're going to talk about some different properties of exponents. All right, so exponents mean that we have something to a certain power. It's repeated multiplication. I want to talk about a few things. When I talk about something like maybe 2 to the third power, I'm thinking about 2, the vocabulary word for the number 2 is the base, and the vocabulary word for the 3 is the exponent. And when it's written as 2 to the third power, when it's written as a power, that's called exponential form. When it's written out as repeated multiplication of the base, that's called expanded form. Okay, so just a little bit of a review of the vocabulary for this unit, just so that you have it. We're going to be using that throughout this video, so I just wanted to clarify that. Okay, so we're going to talk first about multiplying two things in exponential form that have the same base, and we're going to talk about combining them together. So we're just going to look at a few examples here where we're going to kind of explore and figure out the rule by looking at this. So if I have 3 to the fourth times 3 to the second, I can think about it as having 3 to the fourth, that's 4 3s, times 3 to the second, that's 2 more 3s. And then it says here I want it to rewrite with a single base. So I can count them all up. That means I've got a total of 3 to the 6th power. And that'll work for even if you have, think about x to the third and x to the fifth. Got 5 x's and 3 x's multiplied together. That gives me a total of x to the 8th. And so this comes to our first rule. For any non-zero value of the base, okay, and integer values for m and n, so we're only talking about negative or positive whole numbers, okay, for the exponents. When we multiply two numbers with the same base, we just add the exponents. So for example, 2 to the 7th times 2 to the 2nd would be 2 to the 9th. T to the 1st times t to the 28th would be t to the 29th. And then 199 to the 3rd, 199 to the 9th, it becomes 199 to the 12th. And this only works when you're multiplying two things with the same base. So make sure that you remember that. I'll leave this last one for you to try. Okay? Next, we're looking at taking something to a power twice. So it's called power property. We see that we just have one base to a certain exponent, and then we have another power on the outside of the parentheses. So we're going to rewrite it thinking about having this first part inside the parentheses to the second power. I can think of it as 4 to the 5th times another 4 to the 5th. And then this builds on our last power property, or multiplication property of exponents, is that if I multiply two things with the same base, then I can just add the exponents. So this really becomes 4 to the 10th. Okay? So taking 4 to the 5th to the second power is the same as having 4 to the 10th. If I look at the next one, I've got x to the third to the 4th. So that's like having x to the third 4 times. And adding all those together, that gives me x to the 12th. And then same thing here. This is like having xy times xy, and remember this is really like x times y, 3 times. And so another part of that is that if I've got a product of two things on the inside of the parentheses to a certain power, what I can do is the same sort of idea that I would have x to the third and y to the third. So the power property goes in two ways. If I have a certain base to an exponent and to another exponent, I can just multiply those exponents. So for example, x squared to the 4th becomes x to the 8th. And then if I have a product of two factors inside the parentheses and an exponent, I just apply that exponent to each of the separate bases. So I've got 3x to the second. I get 3 to the second times x to the second, which then I can simplify to 9x squared. Now this is only when I have factors inside the inside the parentheses. Remember back to our last unit, if we have something like x plus 3 squared, that does not equal x squared plus 9. Remember that when I have a binomial squared, I have to think about taking x plus 3 times x plus 3, which means I have to FOIL and I get something like x squared plus 6x plus 9. You get a third term in there when you multiply a binomial. So this power property only applies to having a product inside the parentheses. So let's look at this next one. I've got 2x squared to the third. So I'm going to apply the third to each part. So I'm going to apply 2 to the third and x squared to the third as well. 2 to the third becomes 8. And then I'm going to multiply the 2 and the 3 to give me x to the sixth. Okay? So 2x squared to the third becomes 8x to the sixth. And then the other thing that I'll remind you of is if maybe you forget these shortcuts, these properties are shortcuts, you could always write this out. So if I have 2x squared to the third and I'm not sure about it, I'm going to do 2x squared times 2x squared times 2x squared. And then I'm going to think about combining everything I can. So that gives me 8, because 2 times 2 times 2 is 8. And then add all those exponents together to give me to the sixth. All right? Leave that last one for you to try. Okay, now we're going to talk about dividing. So we're going to talk about looking at division of two things that have the same base. Okay, so what I'm going to do is I'm going to think about this kind of like a fraction, where if I had 5 over 5, those would, in some way, they would cancel out to give you 1, right? So 5 and 5 kind of can cancel. So if I have 5 to the 9th, that means I'm multiplying 5 9 times. And then 5 to the 6th means I've got 6 5s. And the 5 over 5 becomes 1. This becomes 1. 1, 1, 1, 1. So I have a whole bunch of 1s multiplied, and then I've got 3 5s at the top. So 5 to the 9th divided by 5 to the 6th actually becomes 5 to the 3rd. Okay? So let's look at this next one. It's like having 3 3s and 3 5s, 1 3, and 2 5s. So this becomes 1 and 1 and 1. I've got a 1 left in the denominator. So this over here, I forgot to say, I've got 5 to the 3rd in the top, I've got 1 in the denominator. And remember, having 5 to the 3rd with a 1 in the denominator is just going to leave just 5 to the 3rd. So here I've got nothing left in the denominator, so then I've just got 3 squared times 5. Okay? Let's look at this last one. I actually want to change this, so can you cross that out? I want you to rewrite it as something like 4 to the 4th over 4 to the 2nd, and then let's put x to the 3rd and x to the and just an x on the bottom, or x to the 6th on the bottom. Okay. So I'm going to think about having 4 4s and 3 x's on the top, 2 4s and 6 x's on the bottom. Okay. So I've got these canceling out, and I've got these canceling out, and I'm left with 4 squared in the numerator and x to the 3rd in the denominator. So I guess my point is that sometimes you have some left in the denominator. If you have more x's or more of that base in the bottom, you have to think about it that way. So one way to think about the division property is that you're subtracting, okay? So b to the n divided by b to the m is going to give you the same base with n subtract m, okay? So 6 and 5 I can't do anything with, and sometimes that happens, so I'm going to leave those. But I can take x to the 9th and x to the 4th, and I know 4 of these x's are going to cancel out 4 of the x's in the top. I'm going to take 9 minus 4. That gives me x to the 5th, okay? So let's simplify this top part, because I can see that I have an x squared and an x to the 4th, so I can multiply those. I can also multiply 3 times 8. So I'm going to multiply 24 x to the 6th divided by negative 4x to the 3rd, and then I'm going to reduce. 24 divided by negative 4 gives me negative 6. X to the 6th divided by x to the 3rd will leave me with x to the 3rd. because remember 3 of these x's will cancel out 3 of them at the top, leaving me with 3 x's left over and a 1 in the bottom, which I do not need to write. All right? 7.5 times 10 to the 8th divided by 1.5 10 to the 3rd. I'm going to divide the numbers, so I'm going to divide 7.5 by 1.5. Oops. Which equals 5. Times, no different than this one, multiplying the 24 times the x. We're just multiplying it times the power of 10 this time. 10 to the 8th divided by 10 to the 3rd gives me something like 10 to the 5th. Okay? Leave that last one there for you to try. All right, and then we're going to talk about something that can happen. Remember I talked about in the last example getting x to the 3rd left in the bottom. You could also think about this problem as having, we had x to the 3rd in the numerator and x to the 6th in the denominator. And if I followed my rule of doing x to the 3 minus 6, that would give me x to the negative 3. The other way that we thought about it was having 1 left in the numerator and 3 left in the denominator. Having x to the 3rd, negative 3rd, and 1 divided by x to the positive 3 is actually the same thing. I have one more way I kind of want to show you this. This has to do with negative exponents, and also 0 exponents, is this. So let's look at using 2 as the base. So if I have 2 to the 3rd, I get 8, right? If I have 2 squared, I get 4. If I have 2 to the 1st, I get 2, right? And what I'm going to look at is the pattern between these exponents. To get from 8 to 4, I divide by 2. To get from 4 to 2, I divide by 2. So to get to the next level, I would divide by 2. And I look that I'm decreasing the exponent by 1 every time. So that means that 2 to the 0 will be 2 divided by a 2, which is 1. So something to the 0 power is actually 1. Now I can do the next thing. I can also divide by 2 again. So I can think about moving down 1 in the exponents. That actually gives me 2 to the negative 1, which would be 1 divided by 2, which I can write as a fraction, 1/2. 2 to the negative 2, divided by 2 again, 1/2 divided by 2 is 1/4. 2 to the negative 3 is 1/4 divided by 2 again, that's 1/8. So what I see is that 2 to the 3rd and 2 to the negative 3rd are reciprocals, because 2 to the 3rd is 8, and 2 to the negative 3 is 1/8. Okay? And also the other thing is that 2 to the 0 equals 1. So when I look at this last part here, I see that negative exponents we can think of in 2 ways. Okay? B to the negative n equals 1 over b to the n. So that's that same thing. 2 to the negative 8th is the same thing as 1 over 2 to the 8th. Okay? So let's look at a few things here. So like y to the 7th divided by y squared. We know that we can subtract those, we get y to the 5th, no problem, right? But then we look at the next one and we see we've got a squared and a 4. We've got a bigger number on the bottom. So we can think about this in 2 ways. We can think about it as 3 to the negative 2 by subtracting our exponents, or we can think about it as having 1 over 3 squared because I'm canceling out 2 of the 3's in the bottom. Okay? And then I know that because I'm thinking about this in 2 different ways, these have to be equal. Okay? So that's just what this first part shows us. Okay? The other thing is that if we've got a negative exponent in the bottom of the fraction, we can think about the reciprocal of it and changing it to the positive. So if I have 1 divided by a negative exponent, I can take the reciprocal and make the exponent positive. And then the last thing that you just have to kind of remember is that anything to the 0 power is 1. So this is kind of like, having 7 to the 4th divided by 7 to the 4th. Thinking about it in 2 ways, This is kind of like using our subtraction rule, 7 to the 0. Or you can think about having 4 7s in the top and the bottom, cancels everything out and leaves us 1 over 1, which equals 1. Okay? So I want every expression to not have a negative exponent, so here's what I'm going to do. I've got 7 to the 5th divided by 4 to the negative 7th. So I'm going to actually split these out. I'm going to think of this as 7 to the 5th over 1 times 1 over 4 to the negative 7th. And then I know that to get rid of this negative, I can take the reciprocal of this second fraction. So what I can do is I can think of this as 7 to the 5th over 1 times 4 to the positive 7th over 1. I just flipped it around. So the way to rewrite this would just be 7 to the 5th times 4 to the 7th. In the same way, I can take this one and write it as 25 times x to the positive 8th. This one, I've got negative exponents in both, so I can just take the reciprocal and think of 2 to the 8th divided by 5 to the 3rd. All right, last one for you to try there. And then I think that should be about it. When you come to class, we've got some problems to try, so don't forget to go back through each section and do the you try problems before you come to class.